Okay, so we already have a texture map directory that we have already created. Shadow map. Okay, and these are the kind of, so we can modify this file itself. So I'll remove this and shadow master.txt. So we have only one file, text.py. So this is what we have been seeing in the shadow map tutorial. So I'll just have a copy of it. And wherever it is required, we will modify it. Okay, so we'll have a function called normalize from sklearn. Okay, so probably I can just go through it. So there is a init function, and inside the init function, we create a frame buffer, and then we create texture object, and then we fill the texture object. We load the image as none. So it is a to a frame buffer in a GL depth component as the type of the its image type. So that we set, and then we call frame buffer texture 2D. So its idea is that the frame buffer, whatever the frame buffer is drawing, it should come as a texture and as a depth attachment. So that is the idea, and we have set it as float. So maximum it will go as 1, the depth, and then we draw it, and then in the display first is this is the texture pass, and after the texture pass we whatever is drawn on the texture, so that we push in the image, and then in the final pass we calculate the from the light vector what we showed in the final pass. Okay, so first is a texture making pass. So texture making pass, actually it creates the texture. Texture making pass create the texture. In final pass, from the light source we again take the calculation, and whatever S and T we receive, so that S and T we map in the texture with the minus Z as a depth, so that this value then we compare, and then from the camera we actually draw, and in the shader we do the computation. So that is the concept behind it. Okay, so this is the final pass, and in final pass, in one go, first from the light everything is calculated, and then from the camera perspective we do other stuff. We reshape, and we set the GLU perspective as 45, and okay, and then we we draw it. So this is the shader code. Okay, so these are neatly explained in the shadow map tutorial. Okay, so we'll modify the code, and first we'll see the problem what we are facing, and then we'll see the resolution. So I'll add from sklearn, because we'll need to import pre-processing. So here this should help in calculating the normal of two vector. Sklearn import pre-process math numpy re pil shadow texture none 256, and okay, nice. I'll add light position rather than hard coding it. So we'll initialize it here only. So minus 15 and 10 and minus 10. So this is light position, and then we'll add cube position equal to 0, 5 and minus 10. Okay, so we'll add a normalize. Okay, so this is the grammar for normalizing a vector. Okay, preprocessing.normalize. So whatever we are getting NP vector, so we convert it to NP array, and then NP axis, a new axis, okay, and then axis is equal to 0. So this is how we do kind of a column by, then we reshape it to 1 and -1 and to the list. So this is how kind of we normalize. Okay, so normalization of the pre-processing from the scalar, it needs a kind of a reshaped vector in this fashion. So once kind of normalization is done, then we reshape it to one row and any type of column. So in single row, so then we take the 0th one and then we do list. Okay, so these are kind of local code you may not find anywhere. Okay, so that is what it is. So now in init, I don't think we need to change. So GL clear color depth test. So we create the frame buffer, then we create the texture object. We bind the frame buffer, we bind the kind of texture object. Then first we'll see the clamp to edge, then we'll see the repeat, and both should be resolved. So that is the idea. Okay, nothing changed, and then we do frame buffer texture 2D, and then we check for the error, and then we release the frame buffer. Okay, so draw, I'll see if something we see that is different. So that will code. Okay, so along the x-axis we'll make it -3. So wherever the light position is, we'll draw a cube, white cube, and along x-axis it will be -3, so that the cube should not come in the front. So that is the idea, and I don't think there is any change. Then we draw a kind of wire cone. So instead of a sphere, so we will have a wire cone, and we'll try to draw it at the center. So there is no meaning of translate now. Okay, so no, sorry, so that wire cone would be at some location. So GL translate. So rather than hard coding it, so this is why we have pushed the light cube position. Okay, so this is the place. Okay, so this is the place where so we'll say kind of cube position. This is this position. So if we see, I believe it is more clear here. So this is cone position, this is origin, red spot, and then this is light position. This is one surface, and this is vertically yellow surface. So 5 things we need to draw. So that is the idea. So this is the kind of instead of wire sphere, now it is wire cone. So I would delete it. Wire cone, and 4, 10, 32 and 16. Okay, so 4 is the base radius, 10 is the height. Okay, GL push matrix, translate it to -20. So we color it, and then a kind of we'll scale it. So we will not draw the table, we'll draw a surface. So we'll scale it to kind of 60, 0 and 60 in X and Z direction, and it will have 1, 1. So this is how it is. Then we have yellow stuff, the vertical one. So color is yellow, and we'll translate it to kind of 30, 0 in the x-axis, and we'll scale it to 60. Okay, so probably no rotation. We don't need any rotation. We'll scale it to 60, 60. It will be kind of bigger. Y and X direction, and that's it. GL push matrix, GL color, and I believe we are done. So this is yellow stuff. This is yellow plane. Okay, so it is at X 30, and then we scale Y direction. And this is the flat plane. This is down one. Okay, so minus 20 down, and then X and Z direction it would kind of expand. And then at the center, okay, so this is the cube. This is the kind of wired cone, and then this is the cube position, and this is the origin. Okay, so we are done. So we'll change display. So this is the stuff. Okay, so uniform load shader. Appear GL color buffer bit reshape shadow height mode equal to shadow. GL you look at. So from light position, so this would kind of change west. So now we will kind of so this is the place where we are receiving the error. Means if we look at the sphere, then it is multiplying. If we look at origin, then probably it is not multiplying. This is what we are saying. But if you look at from the light position, if we look, then it is multiplying, and this is required because there was some problem there. So cube position. Okay, so light position, cube position, and then we will change kind of. So light position is where the light is kept, and cube position where it is seen. So this is light position. This is light position. This is cube position in the sense cone position, and then it will see. Okay, so this is the exact code. Okay, now here we have to do a lot of things because we need a normal in the sense that probably I can edit it. Okay, so if it is seeing from this to this in this direction, then the camera should be, the camera up vector should be in this direction. So it is not Y. Can we see this? Okay, it should be perpendicular to kind of what we are seeing. So that is issue. So now what we'll do is we'll calculate a plane that would be perpendicular to this first. So if I do kind of okay, so Okay, so if we know this vector, yellow vector, okay, so if this vector, I think we'll type it first. Okay, it's quite difficult to implement. Normalize NP cross NP cross NP subtract Q position, light position, subtract Q position, light position. Okay, so first we are kind of Q position to light position. We are kind of calculating, and then we are crossing with y-axis, and where it comes, okay, and that we are crossing again with the Q position and light position. So idea is that we take the y-axis, this is y-axis and yellow line. So this, it makes a plane, okay, so there is a plane that constitute if kind of so this is a plane in that direction. Now if I take cross, then we get another green line that is perpendicular to it. Now green line and yellow line, if I take cross, then I'll get this. Okay, so these are local code, means we have kind of seen this. Okay, so this way we can get this reddish color arrow. This is what we want. We don't want look camera vector in this direction or this direction. This is the direction what we want. Okay, now GLU uniform, I believe it's all right. Load identity and draw. Okay, so we will get the photograph the way it is. I don't think any change is required. And then GL color, and then GL look at. So we'll copy paste here. So look at would change here also in the second pass. Okay, so no more this is the look at. So look at is what we typed here. Okay, from the light look to the Q and then kind of point in the vertical to vertical kind of vector. Okay, so this is how it is. Okay, so GL active texture 0, and then I believe it's all right. Okay, so it's all right. We'll see if we are really able to get output, or we can modify it. It's some bigger like 100. So from Z direction it would see, and it has 30. Okay, and then it is okay, reshape as 45. Okay, so load shader will keep as it is, so that we can see the defect. Okay, so nothing is required. Now if we are able to kind of reproduce it, then we'll fix it, hopefully. Okay, so there is no clamp to edge, the what I was expecting. Okay, so we'll try setting it. Kind of more near, we'll try. Oh, so light position we are overriding. So we'll try again. Oh, so there is problem. Okay, so we can see that there is clamp to edge. So there is an issue. If we make GLU look at from the light source to the okay, so I can rotate it. I believe it will be more visible. Okay, so instead of here, I can just say kind of GL rotate. GL rotate 90 degree along Y axis, and then GL translate so that it will be little far. Let's try if we can able to rotate it. Okay, it's so we rotated it, and this white is light source. This is the cone. Now clearly we can see if it is pointing, looking at the cone, then it is clearly a clamp to edge. Okay, I can move the light source, so it's prominent. Okay, now we can see that the origin where red ball is there, red ball is also coming into the picture because light source is seeing in that direction, and red spot is also coming. But if I move like this, then red spot would vanish. Okay. Okay, so if I put the light source near, okay, so red spot vanished because it is looking only at the cone. So in that projection first term, red spot is not coming. But if I move it far, then red spot is coming. So it is coming in the first term. So I believe I can bring it back. Okay, so we can see that red spot is not coming here because it is looking. So if I kind of increase the distance, so if I say increase the distance, then red spot would come because it will come in the first term. Okay. But if I move it near to the so it is only kind of so these are kind of it is not highly usable. Okay, I can show it with the repeat also. So clamp to edge we have seen. Now I can kind of comment it, and then I can say GL repeat. So problem would persist and it would repeat. It is repeating. Okay, so that is the concept. So how to avoid it? Either I can kind of see from the large distance, means this is not a solution. Then kind of, so if I see from the large distance, then this image would be big. Okay, so no need to repeat. I mean, this is what I want to say. So if I can make it as minus 35 it is looking. No need. Still problem is there, but it is less. Now it is repeating, so image is big. Whatever image it is drawing, I believe we can see it. Okay. So this big image it is drawing. Okay. Left side is white. This proves that it is seeing the far. So it is crossing the table. Yellow kind of whatever we have this yellow plane. It is from left side. It is seeing crossing the yellow plane. That's why it is coming as white. And then this big image is coming. So we are talking about the image size. So image size is bigger. If image size is bigger, then repetition would not be the way it is like this. Okay. So less repetition would happen. So that we can see that there is less repetition that is happening. Okay. So the image is big. So repetition happens from here. So if I set even bigger, then it would completely go away. Then image side would be kind of so image side would be comparable to the screen size. So one image will come, that's it. That's it. No repetition is required. Means it is far away. So big image is appearing. If we bring it nearer, then the image taken by the light in the texture. So if I see the image, now if I see the image, then image is very big, pretty big. So no need to repeat it. This is what I am trying to say. So if I bring it near the way we are doing, then repetition is required. Now if I browse the image, so both images are gone. Okay. So this is the image. Now I am not going to close it. And I'll make it kind of a 65, 55. Okay. I'll browse the image again. So certainly, okay, it is bringing in the same image. Okay, so I'll keep it and I'll rename it so that we can bring. So this is 55. Image name is. So this is image 55. Now I'll make it 15. Okay, now I'll check the image again. So there is a difference between these two images. So the camera which is catching the image, so both images are different. That we can see. This is a big image. This is very small. Only this portion is coming. So image size. So since this image is small. Okay, since this image is small, this is pertaining to repetition. Okay, so if image taken from the light source is small and screen is big, then it will go for repetition. If image is big, if image is very big, means this cone looks small in front of image, then it is kind of the size is comparable to the screen size. and then there is no need for the repetition. I mean, what I am trying to say is, okay, so if this image is big, if this image becomes big, if this image becomes big, it is comparable to the size of the screen, so it will come as full, no need for the repetition. But if image is small, then it is not comparable with the size of the screen, so it will repeat. Okay, so this is one solution. We keep, I mean, this is not a solution at all, but for kind of sake of easy life, that, or we can make, so I'll make it 15, so it is 15, so error is there. Error is there. Now I'll go to GLU perspective and I'll change the angle more, like 75, so that it would see many things. Still, it is better. We can see that now image is bigger, so it is seeing like this. So I can increase even more. No one stops us. Kind of 90. Okay. So very nice. So there is nothing, no problem. Means little bit is there, but it is far better. Okay, it is far better to this. Okay, this is with 45 angle, this is with 90. So again, image is coming is big. So these are the way kind of we can think of workaround. Okay, so we'll come to the actual solution, what we are proposing. So I'm going to reset it to 40 to 45, and this is minus 15. So everything is nice. Now we'll go to kind of shader code. Okay, first I'll show problem is there. Problem is there. It is repeating. Now I'll go to shader code. Okay, so if we see the shader code, in the shader code, we kind of we calculate the distance from the light. So whatever the texture 2D. So we are talking about texture unit. So texture unit is a guy which takes texture coordinate as input and then return the color. So here in the shader code, if you see, texture 2D is a kind of API which takes the shadow map. Shadow map is the texture unit. Where is Mr. Shadow? Here. Shadow map is a sampler 2D. Okay, so in the code, if I search shadow map, okay, so we are using kind of texture unit as 0. So GL active texture 0. So that 0, okay, so shadow map we are setting it to 0. So 0 is the texture. There are many texture units that we can use kind of for the blending kind of series of texture unit we can use for blending functions. So here we are using the 0 one. So now, so sampler 2D, so texture 2D shadow map, or we can use simple texture also, I believe it should work. So shadow map is the texture unit, and we are passing the shadow coordinate that we are receiving from the second pass as ST, and whatever comes the value in the texture. So texture, whatever we are getting, these textures are nothing but they are depth value in float. Okay, so their depth value in float. I believe we have shown it many times. Okay, so I believe I can show it again. So raster text. So I'll draw it again. It will take some time. Okay, so it is not taking a texture. So we'll check the version. We have not used the version. So compile shader. Okay, so I'll use the version. Version we can take 140, then it would support texture also, not require texture 2D. Let's check. Version 140, so it should come. Okay, so alright, it took some time, but I believe file is ready. So this is the file, this is the image file. Okay, so it is nothing but the distances in 0, 0, 1, 1. So okay, now okay, so texture map shadow coordinate st if we pass, then whatever we receive the value, so that depth value we take. So this is the distance from the light source. So this is the okay, so this is the distance what we are getting from the nearest sphere. I mean, this is clear. Okay, so now I am going to set it as a fixed. So float distance from light equal to 1.0. Okay, so this is the fixed distance we are taking, and I am not going to calculate this way. Now I would say if shadow, okay, so believe I can copy paste. Okay, now whatever the distance we are calculating from here, okay, so that distance will manipulate in other way. So shadow chord dot s is less than 1.0 and shadow chord dot t is less than 1.0 and shadow chord dot s greater than 1.0 and shadow chord dot t greater than 0.0. If this is the case, then please go ahead and do the okay. I removed it, then I put it again. Okay, no problem, I'll put it here. Okay, so distance from the light is kind of, this is the way we are calculating. So now what we see here in this solution. So this is the solution. Okay, first distance from the light, whatever the distance we are calculating here, we initialize it to 1. So maximum distance. And now if shadow chord dot s, so now in the second pass, so in the second pass from the light, we calculate the S and T, and then we see in the kind of texture what is against the S and T, what is the depth value. So if shadow chord dot S less than 1.0, T less than 1.0, greater than 0.0, T greater than 0.0. So what we are trying to do here is, whatever mathematics, okay, so here if it is inside this from 0, 0 to 1.0, if it is inside this, then only like here we are doing calculation for the full screen. Means this is the screen that is seen by the camera. Can we see the big screen? And whatever we see inside the green, this is the seen by the light. So this is the image that is been captured. So that is this image. Okay. So then we do the calculation against the image. So calculation would happen only when it is inside the image. If it is coordinate is outside the image, I consider it as external. So fixed is external. 1. If it is inside it, then only we modify the distance from the light. Otherwise we don't modify. Earlier we were modifying for everything. And this texture that was returning the color. Okay, so texture unit, if we specify the texture coordinate, then it returns the color. So texture unit, this is the texture unit. If we specify the coordinate, then it returns the color. Color is nothing but the depth value that we are receiving. Everywhere we are returning, and it is duplicating as per the nature we have set. Here in the texture object we have set it repeat. So it is repeating. It is going there and it is checking. So this is the kind of this is the texture unit. Shadow map is the texture unit against all the S and T. If it is beyond the image, then it goes to texture object, and it does means this is what it is doing. Texture unit, if it receives the texture coordinate, then it is checking the texture object and then taking the texture wrapping, and then it does the grammar that we don't want. So we want do all those stuff only when you are inside the image. Outside the image, consider it as 1. That's it. Okay, so this fix took time. Means it looks very straightforward, but this fix took time. Now it is kind of if depth projection is greater than 0, and then we go ahead with the whatever calculation we are doing. So if it is 1, if distance from the light is 1, then certainly it is not less than this. So in that case, okay, it is 1. If this is 1, then there is no shadow. So around this image, we are forcing it to be no shadow. Shadow calculation is happening only when we are inside this image. Okay. So if distance from the light is fixed 1, it is never going to be less than shadow coordinate -1. In that case, it is 1. Otherwise, it is 0.5. And this is what we will. So we'll try now. Means we have done all the engineering. So we'll try now. Nice. Okay, so there is no kind of repetition. Okay, it is taking time because we are saving in the. So we will not save always. I think it's clear. Okay, so we will not save. Nice. So crystal clear. No error. You can do whatever you want. So nice it is. Nothing. No problem. Amazing. If we are increasing the distance, the red spot is also coming. If I am decreasing the distance, okay, so nice, no issue at all. Okay, so I'll try with the climb page. We can see everything is intact, -15, and GLU perspective is 45. Okay, so I'll see the climb page. That should also vanish. I shall comment this repeat. No problem. It is like a rock solid now. No error at all. Amazing. Okay, so kind of there is a really bug if I don't fix it, so that I'll show and then we'll close. So I'll comment this, I'll uncomment this, and then I'll comment this what we have done. So this is what the change is. So distance 1, so everywhere now it is calculating, so this mathematics we are not doing. And then we'll try if problem persist. Okay, so there is clamping in the edge. If I see clamp edge instead of repeat, then there is a repeat.